So now question 4 on the sheet. We're told that the ship P is moving north at a constant speed of 20. So that's this one. And Q is moving southwest at a constant speed of 10 root 2. So if it's moving southwest, that's telling me that this angle here is 45 degrees if it's moving southwest. At a certain instant, P is positioned 50 kilometres due west of Q. So the distance between the two of them, 50 kilometres. You've got to find the velocity in P, the velocity of Q, and the velocity of P relative to Q. Okay, so let's, in terms of I and J, the velocity of P, you can see that P is heading north, so it's 0 on the I direction, 20 on the J direction. The velocity of Q, the VQ is over here. Now what I'm going to do is to get it in terms of I and J, what I have to do is draw a right angle triangle around Q, like this, and find the I component and the J component. 10 root 2 is the speed, that's the hypotenuse. So this component here, if I take that little right angle triangle that I've just drawn, that's the angle, so this is the adjacent side. So this one will be 10 root 2 cos 45. And of course, this one over here is going to be 10 root 2 sine 45. So they're my two components for the IJ identities. So I can see that it's moving in this direction along the I-axis, so negative I direction. So minus 10 root 2. The cos of 45 is 1 over root 2. So 10 root 2 by 1 over root 2 in the I direction. And this, of course, is the J direction. And it's going again in the negative J direction. So it's going down. So this is going to be minus 10 root 2. And again, the sine of 45 is 1 over root 2 in the J direction. So that vector minus I minus J, because it's moving to in the west and south. So this will become then just minus 10I minus 10J. Okay, so that's the first part. Now the VPQ is the third part. Find the velocity of P relative to Q. So I'm going to say 0I plus 20J minus the VQ, which is minus 10I minus 10J. So that's going to give me 10I and the positive I, and 20J plus 10J, that will become plus 30J. Okay, so that's my VPQ. Now, find the shortest distance between P and Q in subsequent motion. Okay, so I'm going to redraw my diagram. I'm going to position P and Q, and because I know what VPQ is, what I might do is put my axis there. So here's P at the origin, we'll say, and here's Q. Q, of course, remember, is west of that. Okay, so at this moment in time, they're 50 kilometres apart. I don't have to move anything to the origin. It's already at the origin for me here with P. So this is my line. My VPQ line is 10I plus 30J. So it's 10 in the I direction, positive J direction. This angle here is alpha. So this is going to be, I'm going to find the magnitude of VPQ, and I'm going to get the direction of VPQ. So tan of alpha is equal to, of course, the J over the I components. So the J component is 30, the I component is 10. So the tan of alpha is 30 over 10. The magnitude, of course, is the square root of the I component squared plus the J component squared. So that's going to be 100 plus 30 squared will give me 900. So that's going to be square root of 1,000, which of course is 31.62. So VPQ is going to be 31.62. That's my magnitude. Right, so this angle here, which is second function tan of 3, when I work that out, that becomes 71.57 degrees. Okay, so now I'll have all my information. I'm going to put that line VPQ in. So here it is that kind of direction. I'm going to put it passing through P because it's VPQ. So I always put it passing through the first letter. So that's VPQ there. This is going to be here now. That's the D, that bit there. That's my D. So I know what the angle is, alpha. Here it is. So I'm going to say that to find that distance here, D, this is a right angle triangle because I've dropped a perpendicular. The sine of alpha is D over 50. That means that D is 50 times the sine of alpha. And of course I know what alpha is. I said it was 71.57, so it's the sine of 71.57 multiplied by 50, and that will give me 47.444 meters. Oh, is it meters or kilometers? I think it's meters in this particular case. Yes, it is. So 47.44 meters. Okay, so that's that one.